Hello, everyone. Welcome to our first MQ stream session. The session is about exploring IBM MQ on containers, and we have two great presenters today for us. We're gonna go straight into it. We did discuss with presenters how they want to take their questions, so we're gonna have questions. If you have any questions, just post them in the chat, and at the end of the session, we will discuss them all together. And you're all gonna be on mute. So if you, I don't know if there's an option to raise hand, but also if you want to speak, just put it in the chat and we'll sort it out. But without further ado, I'm gonna give you the chance to present yourself, Tim. Now, yeah.
Okay, thank you so much, Raminta. Yeah, so we're gonna start with start by doing the agenda, and then we've got introduction of meetings. So in the session today, we'll meet each other. Then we have some recaps. So today's session is all about MQ on containers. We're going to talk a bit about agile integration with messaging. We'll then explain about the MQ certified container and the MQ operator. And then after that, we get to the really interesting stuff, which is seeing some demonstrations of how to deploy MQ with a CI/CD tool called Tekton. And then we're going to look at a tool called Argo CD, which allows us to adopt GitOps with MQ. And then at the end, we're going to have a short wrap up and just going to explain a bit about the team that myself and my co-presenter peers are from, called IBM Client Engineering. And then we'll have an opportunity for questions. Now, before I move on for Piers and I to introduce ourselves, I just want to call out there three other sessions I saw from the GSE agenda, which has IBMers that we know from the MQ development team and the integration development team. So we've got Gwydion presenting tomorrow at 9 AM on controlling access to your IBM MQ system. Then on Wednesday at 10:30 AM, we have Dale Lane presenting on extending the value of your MQ messages. And then on Thursday at 9 AM, Jamie Squibb is going to be presenting on what's new in MQ. So on to us then. Who are the people presenting to you today? Well, my name is Tim Quigley. I'm a solution architect and I'm in a team called IBM Client Engineering. I've been in IBM since 2010, and I've had roles in that time in the MQ development team. So my first role in IBM was doing testing for MQ JMS with Web Application Server across all platforms. And I did that until about 2015. And then I went into Expert Labs, where I worked on implementing IBM MQ at some of our largest customers, along with IBM Integration Bus and Natalie App Connect Enterprise. In 2020, I was an author on the Accelerating Modernization of Agile Integration Red Book as well. And then more recently, I've moved into my current role, which is more pre-sales orientated and basically is about showing our customers and our partners how IBM MQ on Cloud Pak and containers can work and help solve their problems. Over to you, Piers. I'll just mute myself so we don't get an echo.
So my name is Piers Walter. I'm a technology engineer in IBM Client Engineering, so I work closely with Tim. I've been in IBM since 2019. I've worked in a couple of different teams. Firstly, client success as a full stack web developer, and more recently in client engineering, sort of doing proof experiences and MVPs with clients on all sorts of different IBM technologies, but also including MQ. And I'm really enjoying the role to sort of help customers move to cloud and get involved with Kubernetes and sort of help customers take their first steps with these new technologies.
Perfect, thank you, Piers. So that's us introduced to you. But what we thought would be good is if we could get to know you a bit as well, just so we know who we're talking with today. So hopefully everyone can see in the chat, there's actually a link to join our little survey/quiz on Kahoot. So I've just posted it again in case you didn't see it in the chat. All you need to do is navigate in a web browser to kahoot.it. You can do it on your laptop or mobile device. You don't need to download the app. If you're doing it on your phone, it starts trying to get you to do that. All you need to do is just go to the kahoot.it website and enter the code 9061266. And yeah, I can see you've got Praveen and Raminta here already. And Raminta, can you remind me, Raminta, how many people should I expect on here minus myself and peers?
It would be at least 7 people.
7, okay.
Yeah.
Perfect. So maybe a couple more people to join. If anyone is struggling to get on, if you just post a message in the chat window, and then we can help you out. Maybe there is one more person. Okay, perfect. I think that is 7 people to my count. If there's anyone new has joined in that moment, you can always just navigate straight to this again using the link and join the quiz. It's not going to be locked, so we can start. Okay. Exploring MQ on containers is what this one is about. And first one is going to be a poll. We just want to know what your experience with IBM MQ is. Do you call it MQ series? Been using it for a long time, completely new? You know, since Webs for MQ, or you've started using it recently, say since Cloud Packs were launched in around 2019. We've got a few seconds. Just click the one that's closest. Okay, cool. So we seem to have a spread between long-term users and some people that are completely new. On to the next poll. How familiar are you with containers and Kubernetes? Have you never heard about them? Have you read about them but not used them yet? Do you maybe use them as a side project, or do you use them in your main job role? Okay, perfect. So pretty new to containers in this group then, which is great. We've got lots of content that will get you up to speed. Thanks very much. Okay, on to the next one. Is how familiar are you with Agile integration? Completely new. Maybe you've done some reading. Are you starting to implement those practices of Agile integration, or are you far into your journey of Agile integration? Okay, cool. So we've got some people already implementing those practices, which is great. Some people that are new to this, and some people have done some reading, maybe of the red book that we published a few years ago. Okay, this is maybe the last poll. How about MQ in containers? Have you used these? So did you not know they could run in a container with MQ? Have you read about them, MQ container, but not used it? Have you done it as a side project, or have you actually deployed MQ in containers for your main job role? Okay, cool. So in terms of MQ container, I'd say like we've heard about it, but we haven't been using it physically yet. Okay, on to the next one. These are a bit of fun ones. So which of these is an MQ security feature? Channel desalination, channel consternation, channel authentication, or message browsing? Okay, perfect. So yeah, so everyone got that right, which is fantastic. Although I'm sure many of us maybe have experienced some channel consternation in our time working with MQ when applications are not able to connect. Okay, and now because that was a quiz score one, we get a scoreboard. So Paul, you're on top at the moment. Fantastic. Okay, and then the final one. What does MIQM stand for in MQ? Multi-instance queue manager, master identity queue manager, a many-instance queue manager, or a more insightful queue manager? Okay, multi-instance queue manager. Perfect. Yes. So one of the forms of MQHA that we've had for quite some time. All right then, thank you everyone for that. We have a short podium here because we had two quiz questions. So Raminta, you came third, congratulations. Paul, you came second, and in first place we have Joe. So congratulations, Joe, on winning the short quiz. All right, I'm going to move on back to our presentation. So we had a question about agile integration earlier. I just wanted to do a quick sort of recap to set the scene of where we're at. This slide is sort of showing the journey towards agile integration. So back in the 90s and 2010s, we had this idea of like service-orientated architecture, and many companies implemented this kind of architecture where you'd have your systems of engagement up the front, maybe with some sort of gateway in front of those. At the back end, you'd have your systems of record, perhaps on your back-end mainframes, and then an integration layer or enterprise service bus, which was centralized, was implemented, and sort of that was great because it meant that you had a sort of control in order to be able to connect these engagement applications to your systems of record, but also everything is sort of being centralized through this integration team that's managing that ESB layer. Then we had the idea of socialized APIs came along. So API management became something that people started adopting. At IBM, we have our product API Connect that's been implemented by many large businesses. At this point, we can see that we are then fronting both our sort of integration layer and our systems of engagement with API management platforms, so that we can make easier reuse of both of those types of applications in a controlled and well governed way. In terms of this integration layer here, what we could see as well is that maybe there will be, in addition to the main integrations or a VSB, there might be another part of the business that may start implementing their own integrations as well, and then surface these through API management. Then moving further forwards on the journey, we start to see that we get a more of a breaking down of that integration layer into maybe more microservice type applications. So if you're thinking in terms of things like integration bus, for example, you could have that on having a broker with many integration servers on it. Moving to this fine-grained integration deployment, you might use App Connect, Enterprise, and containers, and have a more microservice-like integration pattern there, still fronted by API management in front of that integration layer. Again, we also see maybe some microservices are being implemented in the engagement layer, and once again fronted by API management. In terms of MQ, you may have some single purpose queue managers implemented for specific microservices as well. That might be something that you were looking at. And then finally, on this journey of agile integration, that's sort of maybe a nirvana type state that I, to be honest, haven't seen many customers sort of get full all the way along this journey. It might be a decentralized integration ownership. Okay, so instead of having everything go through a centralized integration team, there's things and technologies set up such as CI/CD and GitOps, which allow integration SMEs to set guardrails for what is done, but then have line of business teams and application teams be able to quickly implement the integration and messaging that they need as well. So this is kind of the background. It is a scale. I would say that most of the customers I've worked with around MQ and containers have been sort of in these two. So moving from socialized APIs to more fine-grained integration deployment. I'm going to move on now to talk about how we have a messaging perspective with this. So on the left-hand side, we have this sort of more traditional approach where we'd have a sort of a centralized MQ capability. And here you could have a tight coupling between applications and queue managers. So an example of that would be having an application with a locally bound queue manager. The availability of those of that application, that queue manager is linked, so they're on the same server. Another feature of this could be that upgrading this sort of centralized messaging capability is something that can become complex. And because of the way that these systems are deployed, configuration drift can happen between environments, and that's certainly something that I've experienced in the past working with customers, where say some queues that are required or authrex or auth-info that's required across the environment stack are present in one environment but not the next, and then test runs become impacted, as an example there. The centralization of messaging here can be something that might slow down the utilization of messaging by application teams, because there's no way for those application teams to quickly be able to just deploy what they need. So on the right hand side, we kind of have the newer approach that we see people moving towards. So here what we see is we have more of a self-provisioned way of doing things and providing messaging. One of the features is that most of the applications in this case, or maybe all of them, would be client bound. So have a remote connection, for example, using a server con channel. This is a very flexible way of working, because as we move on to something like Kubernetes, it means that we can make use of that for our applications using MQ, scale up and down those client applications using horizontal scaling. And they connect into a queue manager that will scale independently. The other sort of feature that we're going to explore around this is the idea of treating MQ configuration as code. And this is great because it means that we can get things deployed much faster, but also with much more consistency. And we can put guardrails in place as well around it to say, okay, what can people deploy and what people cannot deploy. The decentralizing in this respect as well for this model means that it can be faster for application teams to utilize messaging, because if they're given a way to deploy, say, a queue manager that they need for their application that's got the guardrails around it to say what can and can't be done, they can just kick off a pipeline and get it deployed, and then start using that queue manager right away instead of having to go through a centralized team. And in this model, we have something called operators on OpenShift Kubernetes, which we're going to talk to you about in a minute, which automates a lot of the deployment work of MQ as well. So that's the background on Agile integration. I'm just going to hand over to Piers now. I'm going to mute so that Piers doesn't get double of me.
So there are two ways to get started with MQ containers. The first way is on OpenShift. So this is Red Hat's Kubernetes platform. And we have what's called the MQ operator. And this automates a lot of the deployment and the configuration of queue managers, making it a very simple process. OpenShift has the benefit of running the certified container image. So it's fully supported by IBM, optimized for OpenShift, and very easy to deploy and configure. So MQ with the operator is available on OpenShift, which can run on Z, x86, and Power. But there's also the other option of building your own container. So this is more technically involved, but does give you additional flexibility to what actually goes into your container or your MQ image, you could call it. So this would allow you to run on platforms that aren't OpenShift. So you could run it in a sort of traditional Kubernetes. But the downside is you don't get the benefit of the operator giving you a lot of support and easing a lot of the deployment. So what is the MQ certified container? So a container has multiple different layers within it. So as we can see in the diagram on the right hand side, we start off with the container management scripts. So these run in Golang and Shell, and these allow you to sort of manage the MQ queue manager that's running inside your container. Below that, we have the actual MQ binaries and processes themselves. And finally, so underneath the container, we have what's called a PVC. This is a persistent volume claim. So this is a storage disk which will maintain state even though the container may turn off and on or even scale up and down. This will allow the messages to be retained persistently. Configuration can be baked in a couple of ways. If you create your own image, you can include configuration for things such as LDAP, would be one example of one thing you might want to bake in, because that might be consistent across your whole organization. But for things that are changing a bit more dynamically, you can configure the container through what's called a Kubernetes config map. And this is where you add your MQSC files. And you can also do qm.ini changes as well. So there are two different ways to do it. So baked in is probably things that are a bit more consistent across your organization, and the config map for things you want to change, for example, queues and server con channels, that kind of thing. On top of this, to sort of to support TLS, you can mount secrets into container. So these could be things such as keys and certificates that you want to use for client authentication. And then these are also stored within Kubernetes as what's called a secret and mounted into the container as a volume. All of this is then deployed using the MQ operator, and we'll see an example of this later with the GitOps demonstration on how you configure this. But it's a fairly straightforward process. And once again, this runs on OpenShift as part of either as part of Cloud Pak for integration, or just the MQ MQ can just run on its own as well. You don't necessarily need the whole Cloud Pak for integration around it. So the MQ operator in Cloud Pak for integration. So the role of the operator is to deploy, update, and manage MQ inside OpenShift. So the operator is responsible for doing any updates and maintaining the state of your actual Kubernetes container, so your MQ containers that are running. MQ is configured as what's called a Kubernetes native resource, and this allows you to easily declare new queue managers through YAML files and change your configuration easily. Again, we'll see an example of what these actually look like later, but it means that to deploy a new queue manager, you simply add a configuration file to your Kubernetes or OpenShift cluster, and the queue manager will get automatically deployed by the operator. And so the operator ensures that the deployed state of these, the deployed state on the cluster matches your declaration. And if you change your declaration, then the operator will update the necessary configurations to get everything deployed. And again, we'll see an example of this later. So these are the objects which get deployed on OpenShift. So to start off, we have the MQ operator, and this will sit here waiting for a user to say that they'd like a new queue manager. So once they do that with queue manager custom resource, the operator will then notice the queue manager custom resource and start getting things ready. So inside this blue box is everything that is deployed by the MQ operator, and these aren't things you need to do yourself. So firstly, you end up with a stateful set. So this is used to control containers and make sure that you have the right number of them running, because you might want one, you might want two, you might want three, etc. And just maintains the state of the containers. So this will spin up what's called a pod, and inside the pod you have the container. Secondly, it will then create the persistent volume claim. So this is the actual storage disk. It will allocate a bit of storage and say, we want, for example, 10, 20, 30 gigabytes of storage for this MQ instance, and it will go away and reserve some space. And so in this example, we're using a multi-instance queue manager example. So we have a pod connected to a high availability network storage. The operator will then create a service. So this allows other resources inside your Kubernetes cluster to access the MQ queue manager. And finally, it will also create what's called a route, and this will expose it to the outside world. This is optional, so you can maintain everything within inside your OpenShift cluster, but you have the option to expose it to the outside internet if that's what you choose to do. So pass back to Tim, who's going to talk through OpenShift pipelines.
Perfect. Thank you, Piers, for the explanation of the MQ operator. There it is something that really makes it very easy to get started with MQ on Kubernetes. Okay, so I'm now going to show an example of how we can use a technology called OpenShift pipelines to deploy an MQ queue manager, and then I'm going to do some demonstrations of just connecting to the queue manager that we've just deployed. Don't worry, there's no further quiz at the end if you don't remember everything in here, because there's a lot of information to take in. We're going to give you the broad brushes of what OpenShift pipelines are. So OpenShift pipelines is it's a pipeline technology based on something called Tekton, which is a Kubernetes native open source framework for creating CI/CD pipelines. Now, the key things to remember about Tekton and OpenShift pipelines is that It uses containers as the building blocks for the pipeline, and it runs inside of your, in this case, an OpenShift cluster. Okay. Now you can see here that much like MQ has an operator, OpenShift Pipelines has an operator as well. So it's really like a app store like experience to go and get this deployed on your OpenShift cluster. In terms of how this pipeline works, there are two main concepts I want to explain before I show the demo. So the first one is that Tecton pipelines have things called tasks. Okay, and in a task, basically we can define a series of steps. So in this example here, we have a task called deploy MQ, and in this task we might have two steps. So the first one would be to apply that queue manager custom resource YAML that Piers showed you on the diagram previously, and then a second step might be to then check is our stateful set that looks after our MQ queue manager up and running and reported that the queue manager is there. So an important thing to know here is that in terms of how this is actually implemented, a task will execute inside of a Kubernetes pod, and then a step will be implemented as a container within that pod. Okay, so this outer box is a pod, the inner box is a container. Similar to object-oriented programming, you could say that the task is a class, and then the instance of the task is a task run. So we'll see this as an object when we look at the demo in a moment. The tasks allow us to ingest specific inputs and produce specific outputs, so we can string them together. I'll talk about that in a moment. And we can parameterize these tasks, these inputs to the task as well. So we can reuse the same task to deploy, in this example, lots of different queue managers with different names. Okay. The second part I wanted to explain before I show the demo is that with OpenShift pipelines, surprise, we have the idea of a pipeline, and pipeline is just a collection of tasks. Okay. And so the pipeline will be a YAML definition that will say run this task, then run this task, then run this task. Tasks can be run in parallel, or they can run in series, and we'll see that on the demo in a moment. And the other thing to know is that the steps inside of the task always run in series. Again, pipelines can be parameterized, so we can make one pipeline to deploy MQ that we could use to deploy lots of different queue managers. The pipelines can be triggered as well by an event. So you can set up a webhook on Git, for example, to kick off a pipeline based on a commit to a Git repo. Or we can create a pipeline run definition and apply that on the cluster, and then it will start running our pipeline. And this is what I'm going to do in the demonstration now. Okay. So I'm going to move back here, and we can go and have a look at our pipeline. So this is the OpenShift Container Platform admin UI. When you install OpenShift pipelines, you get this this handy little section here on the left-hand side that takes you to your pipelines and shows you the ones that we have installed. So we have one here called MQ Build, and it's got these series of steps that I'll walk you through in a moment, or these tasks here. What I'm going to do is, because pipelines take 7 minutes, 45 seconds, and the last time I ran it to complete, I'm going to kick it off now, and then we can talk through it. In this case, I'm just going to go and click rerun, so one that I did earlier, and then it starts working. So the first thing that it's doing here is it's running two tasks to fetch our source and our infrastructure from Git. So with CI/CD, we have this idea of separation of concerns. This is an example to show how those concerns might apply separately to MQ. So firstly, I'm going to have a look at infrastructure. So in this repository, I have a template file which our pipeline will process, and the result of that will be a queue manager custom resource here. So we can see that our custom resource is of kind queue manager. And then we can go down and see there are various different items in the specification which will tell the operator what type of queue manager to make. For example, with this one here is a non-production license that's being used because we're just deploying into a sandbox. We can also see that we are mandating that this is a persistent claim queue manager. So this will be a type of a single resilient queue manager. I believe that possibly Jamie will be talking about this a bit more and is what's new in MQ presentation later in the week. Scroll down a bit further. Another interesting area here is that with this infrastructure, we are mandating that the MQ web UI is enabled to true. And also we're specifying the name of the secrets where we want to pick up the keys for TLS. Okay, so we can have TLS connections. Now down here at the bottom, we have some defaults for some of the values that were parameterized above, such as the storage class and the license and the version that we want to use. So the key takeaway from this one really is that, like, if there are some things that you don't want, like all the teams that may want to deploy MQ to change, then you can kind of set them up on the infrastructure level here and then feed that into your pipeline. On the other hand, we have the source here. So Piers mentioned to you earlier that with configuring your queue managers, you have the option to build a container with the configuration you want baked in. And that's what we're going to do here. Or you can apply a config map with your MQSC configuration, which Piers will show in his demonstration. Now, in this case, we have an MQSC file that's defining a few different things. So here we can see we're setting up an auth info object to an LDAP server that we've deployed. We can see that we've got some authrex being set up for our MQ admins group. Interestingly here, we've got a sender receiver channel pair. So later we're going to show you connecting to a queue manager outside of OpenShift to show how you could connect maybe an existing MQ estate on-prem to MQ on Kubernetes. And then further down here, we see we've got some local queues or remote queue set up as well. In reality, I would think that the type of thing you'd want to bake into an image is the thing that you wouldn't want to change between like environments. An example of that might be your auth info object for LDAP, for example, especially if you had a shared LDAP for your non-production environments. Maybe you would want that just to be something that will always remain consistent. And this way you wouldn't have configuration drift possible between environments where MQ is deployed. Okay. So those were the two inputs. The next step here is to build our MQ image. We can go and click on this, and we get a log of what this task has been doing. So basically, what it's done in this build MQ image is it's taken the certified MQ image, it's added in that MQSC on top, created it as an image, and then pushed it to a image registry that's on our OpenShift cluster. The following step here was to apply to run the template that I showed you and then create the queue manager custom resource and then apply that onto the cluster. And then it's got a second step here that we created. It's just a shell script that just checks to see if the stateful set is ready. That means that the stateful set will be ready once the queue manager pod is up and running and it's performed a health check to show it's running. And then in this task here, what we did is we added in a smoke test. So what this is doing is it just checks the test queue exists first, and then it uses the AMQS put to put a test message, and then it uses AMQS get to get a message. Okay, and in reality, this is quite basic. This one, I think, would be something more complex in your pipelines that we'd use for real. But the idea here is that in your CI/CD processes, you can add in these kind of checks to make sure that the configuration that you desire is actually there, so that when you hand over the queue manager for use by application teams, that you know that it's got the right configuration there. Again, many of you will be doing this already on-prem, but this is just how you can do it in containers. Okay, so that is run, and our pipeline is reporting as finished. We've succeeded. Now what I'm going to do is quickly show you over here. Piers talked about the MQ operator. So where would I find it on OpenShift? So what we do have here is this handy bit where you can go and click on the operator hub. That's where you can install new operators. here I've already installed MQ, so I go to installed operators. I've narrowed it down to MQ, so I go and click on here. And then on here, it's got some useful documentation that you can read at your leisure. I want to go and see what queue managers we have. So I already have 5 existing queue managers on this cluster, and they're actually connected in a traditional MQ cluster. So 1 and 2 are the full repos, and the other ones are partial repos. The one that we just deployed is queue manager 6. You can see here that it was deployed just 3 minutes ago. So I'll just click into this, and we can see some of the resources that Piers was talking about just now. Firstly, we can see some of the information that was on that template I showed you for the custom resources here. So like the license number, for example, we got some information about the public key infrastructure that we've set up. Interesting thing with this is that for setting up the TLS certificates, you don't need to create your KDB file and upload it to the container yourself. All you need to do is supply the CA certificate and your private certificate for the MQ server as secrets, and then tell the operator where those secrets are located. Then those the scripting inside of the container that Piers was saying about earlier, that actually pick up those certificates, process them, and then create the KDB file for us, and the stash file as well. So you can see some further information down here. In this case, we're allocating 1 CPU and 1 gig of memory. MQ can actually run on half a CPU, but I upped it when I made this demo before. And then I can go and look on the YAML. So again, this is literally what it's done, is just add this YAML file onto the cluster, and then the operator has done a whole bunch of work for us that we don't need to do ourselves anymore. If we go and click on resources, we can see a bunch of the resources that Piers was talking about as well. So we have a service, that's the durable host name inside of the cluster that we can use to connect to the queue manager. We have a route for external connections, and then this one here is the stateful set. So stateful set is the Kubernetes controller that will look after our pod and container where MQ is running. Key thing about a stateful set is that it will never allow there to be more than the number of pods that we say we want running at the same time. So there are other ways of controlling pods on Kubernetes, such as a deployment and a replica set, that can temporarily allow you to have have 1 extra of the number of containers or pods that you want running. With MQ, we only want there to be 1 queue manager accessing our logs and data at a time. Otherwise, we could end up with things being inconsistent and get into a whole world of pain. So this is why we use stateful set, because we only ever have the number of pods that we want actually acting as a queue manager. If I go and click on pods here, we can see our MQ pod. You get plenty of detail here. For example, we got the volumes where our logs and data are. I showed on this page. And then the thing I wanted to show you here is you can actually go and click on the terminal and run some of the commands that we're used to, like DSP MQ or like run MQSC, and we can display our local queues, for example. Okay, you can also do this from the command line as well. I'm just showing via the terminal. Okay, so we've looked at the operator. We've seen all the objects that creates. We've gone down into the container where MQ is running, and we've seen that we still have MQSC, run MQSC available there. The other thing I'm going to do is just go on to the integration platform navigator, and I'll get the MQ web UI to load up there. Okay, so I get a list of the queue managers. QM6 created 7 minutes ago is the one that we want to show. So I'm just going to click on that. That will load up, and it's going to display our queues. In the meantime, while it's doing that, what I'm going to do is switch across to my Windows server. So I have a Windows virtual server instance that's running on IBM Cloud outside of OpenShift. And I'm just going to use this to demonstrate some connectivity over to our queue manager. I have RFHUtil, which based on the responses to the survey earlier, I'm sure many of you have used quite a lot. We have that running with the MQ client underneath it. Also, I have a queue manager on Windows called QM8. QM7 got lost while I was making this demonstration, but we have QM6 on OpenShift and QM8 on Windows. One thing that I highlight here is I've got a sender receiver channel on this queue manager as well. I stopped this because they were going into retry state when I didn't have the queue manager on OpenShift. So I'm just going to start them up now, and they will bind. Yep, that one's running. Okay, perfect. And then we have some queues on this Windows one as well. So we have a create customer Windows, we have a transmission queue, QM8.QM6.queue, and we have our remote queue create customer OCP QM8. So just bear that in mind, and we'll switch back here and go back onto our QM6 on OpenShift. So let's have a look at the queues on here. So first one is we have a test queue V1 on here as well. And we have a create customer OCP queue. So this is the target of the remote queue on our Windows machine. We also have a remote queue on here to point at the corresponding one on Windows as well, and the transmission queue. Over here on MQ Network, we can see that we have QM8 is connected, and we have some running channels. I mean, this one, I'll just start that one to be sure. Okay, yeah, so they're both up and running. All right, so the first thing I'm going to do quickly, I'm keeping a beady eye on the time because I know we're coming up to our 15-minute warning, is I'm going to load up RFHUtil. You can see that I've set my MQ server variable here. I've also set up my username and password, and I've set up SSL. So an important takeaway from this talk is that to connect through to MQ on OpenShift, you need to use TLS. This is because the way that we can distinguish at the OpenShift router which queue manager to go to is via something called a server name indication, or the SNI header that is added within TLS 1.2. There are options around the MQ internet pass-through if it's not possible for you to add TLS onto your existing queue managers as well. Worth Gwydion Tudor is a person who knows a lot about that, who's presenting tomorrow. Okay, so we have our setup here. We have our data, which is just a SOAP message creating a customer for our fictional client Tiger Bank. And we have format MQ string. Going to write that. It's just going to tell me the connection was lost because the queue manager went away when I deleted it last night. And now we put a message on the queue here. Okay, so if we go on to here and do a refresh, yeah, we can see that RFHUtil has added a message. And then we can see the beginning of a SOAP envelope here. So that's the first one. The second one I'm going to do is I'm going to pop a message on the remote queue here, and we're going to see this go across to our Windows machine. So let's put hello from OpenShift and send that over. So it's not on our transmit queue, so that looks good to me. And if I go on here, then I can see create customer Windows. Indeed has a message, and if I scroll across here, we can see it says hello from OpenShift. So that's great. Let's do it the other way. And I put a test message, and I put hello from Windows, and send that over as well. Close that. Okay, perfect. And let's refresh that there, and we have a message that's arrived on here, and it says hello from Windows. Okay, so what I'm going to do quickly is just show you one slide to add a little bit of context on this. So one question we get asked a lot is, okay, well, how would I connect existing MQ estate to MQ estate on Kubernetes on OpenShift? What's the recommendation? Well, a way that we've seen work really nicely in the past has been having this idea of gateway queue managers, concept that's been around for ages on-prem, but is really useful when we are going into containers, because it gives us this basically an administration point at the edge of each domain where we can configure what we need. So I send a receiver channels between those two, and then from there we can route messages on to where they need to go to. So that works really well, and I would talk about it more, but I know that we've got not much time left now. So what I'm going to do is I'm going to put myself on mute, and I think Piers will talk about Argo CD.
Thank you. So yes, I'm going to be talking about GitOps in this case, and how that can work with MQ. So the idea with GitOps is you have a central Git repository, which is used as your source of truth for the state of your cluster. So we use a technology called Argo CD, which is again integrated with OpenShift and fully Red Hat supported, which can read from a Git repository, decide on the state of the cluster, and add and remove resources as required. So we'll be using this to deploy MQ in a moment. The benefit of using Git, there's a couple of key ones. Firstly, it allows you to sort of control who can and can't modify the state of the cluster. So you might allow, for example, developers to submit pull requests to change and deploy new MQ instances, but you mainly want an administrator user to actually approve that and pull that into the main branch. So you can say to Argo, monitor only the main branch and control what's deployed through Git revision history. Secondly, the other main benefit is it gives you a history of what's changed on your cluster, meaning that if you deploy something and the configuration is incorrect or something's gone wrong, you can revert back to an earlier version very easily just by updating your Git repository. So those are a couple of the key benefits. There are many more, but slightly pressed time, so we'll get started with the demo. So what I'm going to be doing is I'm going to be deploying a queue manager using using GitOps. So here we have a YAML file. So this tells the MQ operator how we want to deploy a queue manager. So again, I've accepted the license. I've set up some TLS keys, as Tim mentioned earlier. And here's where we actually define some of the key things about the queue manager. In this case, I've said that I'd like the MQSD file to be read from a configuration map, and specifically an object in there called config.mqsc, which we can see here. So very similar to the one Tim showed earlier, it contains your standard MQSC. The name of the queue manager is going to be quick start. We want half a CPU of processing, and it's actually going to be a persistent queue manager. So we're going to use storage of type IBM Sleep.Gold. This depends what platforms you're running on. But yeah, it's going to be persistent storage. So the messages would be stored between the pod, turning off and on again. So all I need to do to deploy this is I've made my changes to the file. I just need to commit it to main and push. And so once this gets pushed, Argo CD will notice the change and get started. So if I go to Argo CD here, this is what it's currently got deployed. And in a second, it will notice that the new file's been pushed up. So, oh, I had it locked me out. Lovely. 2 seconds. There we go. Right, log back in there. So here we have Argo CD. So it gives you a breakdown of everything that it's actually deployed. So these are some supporting resources, including the MQSC config that we had, the namespace, which is a Kubernetes thing that's required to deploy it in, a couple of routes. But the main thing we just added here is the queue manager. So all we created was the declaration for this queue manager, and the operator is what's actually noticed that we need to deploy all these other things. So as Tim showed earlier, we see the services here, a couple of services, service account, which is going to be user account for the MQ deployment, stateful set, which actually creates our pod, and inside the pod will be the container, which is where MQ actually runs, and the PVC, which is the persistent storage. So these are just deploying at the moment, hence the little blue logo. So PVC probably takes about 30 seconds to create the first time. And yes, some of the other resources we have down here as well, including the root and some secrets. So simply by adding that single YAML file to a Git repository, that's kicked off deployment of a queue manager. So it makes it very easy for users to deploy new queue managers. So we'll just wait for the pod to create. Shouldn't take too long. But if I go into OpenShift as well, we can actually see what's going on. So we have this new queue manager here, which I created, MQ Persistent, and again, it looks very similar to what Tim showed earlier. But this time we have the MQSC, which comes from this config file. And again, we can look at the config here, and if we need to change it, we can do. Restart the pod, and then MQ will be updated with the new configuration. So we should see our pod is here, it's creating it. You can see it's just waiting for storage at the moment, which is fine. There we go, storage is bound now, so MQ started up. We get our normal MQ output logs, as we can see, and Argo will now know that, notice that this has been deployed. So yeah, PVC is okay, and MQ is still just starting up. But that's okay. There we go. Yep, MQ is all starting up as we'd expect. So in order to sort of test it, I've got a little demonstration application which you guys can access. I'll put the link in the chat. And this is just for, this just allows us to sort of send a message, show hello from here's, and submit that. That gets sent to the queue manager, and we can then get the messages as well. So it is destructive, so once you press get messages, messages will be gone for everyone else. So feel free to mess around with it and try a few times. But yeah, this will be using our queue manager that we have just deployed through GitOps. So if you have any questions around that, feel free to just put them in the chat and I'll address them. Otherwise, I'll pass back to Tim to explain a bit about client engineering and what we do.
Perfect. Thank you, Piers. Let me share my screen again. I've sent a message onto the queue, so hopefully that arrives. Okay, yeah. So hope you've enjoyed the session. I just wanted at the end to talk a bit about our team. So both Piers and I are in a team called IBM Client Engineering. And this team was set up in the spring of 2021. So we're quite new. We're quite a new team, but also we're quite a large team as well. Okay, so basically what we offer is at no cost to our customers, multidisciplinary team and expertise to join you to rapidly innovate and co-create to prove out solutions to your business needs using IBM technologies such as MQ Cloud Platform integration. The value that you get out of this is that instead of just us telling you what can be done, you get to experience it more yourself, and you get to bring your actual pain points to us and work with us to see how they can be solved. So it's a sort of a very collaborative process, which people find really valuable to help them understand, where they want to move to and how they can solve their problems and things like this. What is your commitment to this? Well, it's you need to provide your sort of business and technology sort of context to us. Many of you, I'm sure, from customers that we already work very, very closely with, indeed, given that I think most of you are long-term MQ customers. Again, like integration isn't the only bit we cover. That's one part. It's also automation, data, AI, and the whole range of different areas. And you can see here on the right hand side that we've already completed 2,000 client projects across the world. It's hundreds of use cases. We have over 1,700 people. I'm sure there must be more than that now because we've had some more people join recently. And we've got these different roles here that can help you along. So business technology leaders to sort of identify opportunities where we can help you. solution architects such as myself who will understand the problem a bit more and design a solution that will prove out how we can help. Data scientists as well. We've got technology engineers like Piers, and I think that's about 75% of our team are technology engineers who are hands-on with the technology day in, day out. So we really are an engineering team. And we have designers as well. So designers will help us to facilitate our workshops to learn more about the problem at hand, and also do the real design work for any sort of front-end parts of the solution that needs to be done. In terms of the way that we work with our customers, we have this a method called value engineering, and the idea is that we can work with you very rapidly to prove out how we can help. Okay, so we have this innovate phase at the beginning where we'll understand the business area that we're working with and identify an opportunity, define our scope of what we want to achieve. Then we have a short preparation phase where we create our build team and our co-creation team. After that, we have this co-creation phase of 2 to 4 weeks where we'll work using agile methodologies in a series of sprints. And this stage here, we can co-create with you and get you hands-on with the technology so you can actually experience it and see for yourself and build your own skills. Piers, I didn't know if you wanted to add a few words on the build phase briefly.
Yes, so it's typically about 2 to 4 weeks, as I think Tim said, and every week we get an update on progress. So it can be as involved, or you can let us sort of crack on things as much as you want. So typically we like to co-create and have someone from the client working with us, and that's great to provide their insight. But yeah, the aim is at the end of between 2 to 4 weeks, we'll have something that addresses the pain points of your business, and something working that you can then take away and keep on working with.
Perfect. Thank you, Piers. Yeah, and then at the end of this phase, we have proved out how we can help, and you have learned a lot. Hopefully, hands-on experiencing the technology, and then we'll move into a transition phase where we can work with our other teams in IBM to help you implement a plan to actually realize the value out of what we've learned out of the MVP. Again, this client engineering team is at no cost to our customers. We consider it an investment to our customers. We really love working with people such as yourselves on engagements and having interesting problems to solve, because at the end of the day, we're a team of people that just love playing around with new technology and seeing how it works. So if that sounds like something that is interesting to you, then I really recommend that you could visit our IBM Client Engineering website here and learn a bit more. Also, you can reach out to your IBM representative, who'll be able to tell you more about our team as well. The other thing here is I put a link to the production reference deployment guides. So Piers showed you about Argo CD with MQ. Now there's a whole team in IBM that has produced a reference guide for how you would deploy MQ, App Connect, and API Connect using GitOps, and it's incredibly detailed. And some of our best people worked on making this. So I really recommend going to take a look at that if you're interested. And we've got our other talks by the IBM team on this side here. So I think that is like bang on the time. Happy to answer any questions as we can. I did see one on how to connect from mainframe to use this. Lewis, if you could send me an email address I can contact you on, I'll take that up with you after, because I think I want to go and talk to some of my colleagues in the MQ mainframe team to see what they would advise with that, given the situation with the MQ client on ZOS. But if there are any other questions, I think Piers and I will have a few minutes to answer some now, if we're allowed, Raminta. Sorry to hijack your session.
Yeah, no, it's allowed. I'm just conscious of the time because people plan their time, so we just cautious that some people might need to drop off
Yeah, sure.
at this point. So if anyone has any questions, I allowed you all unmute yourselves now, so you feel free to speak up or just put something in chat. A few more minutes. As I mentioned before, I have posted our feedback form just to make us to allow us to make the conference better. And if you have anything to point out to the presenters as well, please let us know. But yeah, final shout for any questions?
Yeah, hi. Do we get this slide somewhere to download?
They will be attached to the agenda. So yeah, so if Tim will be Tim and Piers will kind enough to share, we will attach it to the agenda and it will be available for you. Yeah.
Thanks.
Yeah.
One more question. So once we deployed the queue managers, right, it will act as same as what is available right now, right? The other queue managers, right? The queue manager functionality.
So yeah, it's inside of the container is MQ Advanced. So that's what we've got deployed. There are some parts of it that in MQ Advanced on-prem that aren't in there by default. I think the AMS part you need to install separately. I think Piers, you worked on one with AMS earlier in the year. But yeah, so it's MQ Advanced is what's inside of the container.
Okay, so it's same as what we have running in other platform, right? The functionality, right?
Yeah. So like so it's the same as like what you'd have on the Unix platforms, basically.
Okay.
There are some caveats to that, because as I mentioned, like some of the RPMs that you get with MQ Advanced aren't in the container by default. So that's detailed in the support documents for it. But yeah, like most of the stuff that you would normally use, like is there. It's not like, okay, queuing is supported but PubSub's not supported, for example. Like it's like the normal MQ functionality for the most part is there. It's like additions like AMS that I think you need to add additionally yourself.
Okay, great. Thank you.
No, you're welcome. Yeah, okay. And Raminta, I wonder, like, is it it's been a request to send, like, there's a question about how you connect from a ZOS-based queue manager, like in the way that I showed in the example. And I need to go away and talk to colleagues about that. But is the best way for people's emails on here to can I get them from you, or do people need to add them here, or
I'm gonna ask you to give me a bit of time as well to make just to check how best to get all the attendees emails, and then we can pass it through. So yeah, let's just work together. If Lewis can want to send an email to you, Tim, and we can later on, we'll share it with the rest of the team. We can do that way. But yeah, let's just keep in touch. I'll coordinate it, so no problem.
Okay, perfect. Yeah, and in the meantime, I put my email address in the chat as well. So do feel free to get in contact with me as well.
Okie dokie. We overrun, so I will cut it short, but obviously I will encourage everyone to, if any more questions, please feel free to reach out to Piers and Tim, or if needs be to me, and I'll pass your own questions. Thank you very much, both. It was a really good presentation and really insightful, and thanks everyone who participated. So yeah, thank you, and hopefully speak to you shortly.
Yeah, thanks.
Thank you.
Cheers all. Thank you. Bye.